Hello, everybody, and welcome to the new video. Today, we'll explore various memory management techniques in operating system. In this video presentation, we will talk about paging, segmentation, demand paging, and swapping. Let's start with paging. Paging divides virtual memory into fixed size pages and physical memory into frames, mapping virtual pages to physical frames. Let's see how the paging works. The operating system maintains a page table for each processes, mapping virtual pages to physical frames. When a process needs a page, the OS retrieves it from the physical memory frame. Now, let's talk about advantages and disadvantages of paging. Advantages are: it eliminates fragmentation. No need for continuous memory allocation or reducing fragmentation. Efficient memory use allows efficient use of memory by loading only necessary pages into RAM. Disadvantages are: managing page tables adds overhead. Frequent page swapping can degrade performance due to page faults. Have you ever noticed your computer slowing down when switching between applications? It could be due to frequent page faults. If you have any experience with this, please share it in the comments below. Now let's talk about segmentation. Segmentation divides memory into logical segments such as code, data, and stack. Each segment has a number and an offset. As you can see over here, it has an offset and also a segment number. The segment table maps segment number to the physical addresses. Let's talk about advantages and disadvantages. Groups related data and instructions together, making it easier to manage and protect. Different segments can grow independently without affecting each other. Disadvantages are external fragmentation, which can suffer from external fragmentation where free memory is scattered, more complex to implement compared to the paging. Now I'm going to talk about demand paging. Demand paging loads pages into memory only when needed, not all at once. How it works is that when a process tries to access a page that is not in memory, a page fault occurs and the OS loads the required page from the disk into memory. Let's talk about advantages and disadvantages. Only necessary pages are loaded, saving memory. Then we have faster startup, reduces initial loading time by loading pages on demand. The disadvantages are page fault overhead. Handling page faults can be time consuming and degrade performance. Latency, initial access to a new page may be slow. Now let me ask you some question. What do you think about the trade-offs between efficient memory use and performance overhead in demand paging? Let me know your thoughts in the comments below. Moving on to swapping. Swapping moves entire process between main memory. It moves entire process between main memory and disk. When the OS decides a process needs more memory than is currently available, it swaps out less active process to disk and swaps them back when needed. Advantages are: it allows more processes to run by using disk space for memory. It is flexible and can handle large processes that do not fit entirely in the RAM. The disadvantages are: swapping to and from disk is slow compared to accessing RAM. Managing the space adds overhead. I hope this video was informative. We all have learned about different memory management techniques in operating system. Please post any questions you may have and I'll try to answer them at my earliest.